Hello friends, today let's review some bit masking or bit manipulation operations or operators. First, let's review some operators. First is called AND. These are two binary numbers. The first, it represents 2 to the power of 0, which is 1 in decimal system. The second is 1 times 2 to the power of 1, which is 2. If we use AND on these two binary numbers, the result should be 0, 0, 0. Why? Because only when two corresponding bits are all 1, then the result will be 1, otherwise will be 0. So in this example, every pair of binary bits are not or both 1, so we just return 0. The second operator is OR. Let's see this example. 1 0 0 0 0 1 1. The result will be 1 1 1. Why? Because if any pair of bits there is 1 is 1, then the result will be 1. So in this example, every pair have one bit is set. Actually, the bit is set means that bit is 1. So in the result, 1 1 1. The third operator is called XOR. Only the two corresponding bits are different, it will become 1. If they are same, then it will be 0. So in this example, this is 0 0, so they are same and 0, so we will give a 0 here. In this example, they are all 1, so that means they are same, so we also return 0. In the example 0 1, they are different, so we will give 1. It's the result. The fourth operator is NOT. Any bit, we just get its opposite 1. So not 0 will be 1, not 1 will be 0. Then left shift and right shift. What does that mean? That means 1 left shift k bits. So for example, this is the previous one, and we left shift this 1 to k bits, k equal to 3. Then we move it to the position on its left by 3. So that's what we will get. The same for the right shift. For example, it's 1 0 0 0. If we right shift 4 bits, then we will get 0 0 0 1. Okay, that's the basic operators. Let's see some basic operations. First, let's see if n equal to 4. For every bit, we have 2 possibilities, either 0 or 1. So in total, there is 2 to the power of 4. So we have 16 possibilities. Let's see some common operation. First is check whether case bit is set. As I said before, set means is equal to 1. So how can we get the case bit? If we want to get whether the case bit is set, then we just need to AND 1 left shift k bits. Let's see example. If I is 4, then we know its binary is 1 0 0, and we want to set its second bit to 1. Actually, it already 1, but what should we do is just AND it with 1 left shift 2, so we get 1 0 0. So why it works? Why it works? Because we only when 2 bits are all 1, we can get 1. So if we AND 1, if it's 1, then we get 1. If it's not 1, then we get 0. So that's why we should use AND to check whether it is set. If we want to set it as 1, how do we set it? We just need to OR 1 left shift k bits. How does it work? Still, if I equal to 4, k this time is 1 because the this bit, 0 bit, zeros, 1 bit is 0, right? So we want to set it to 1. We just need to do this OR 1 left shift 1 because it is already 1. So no matter this is 0 or 1, the result here will becomes 1. So that's the intuition. Check whether it is 1, use AND. Set it to 1, use OR. So on the opposite, if we want to unset the case bit, we want to change it from 1 to 0. How should we do? We should use X or Y. Still this example, I equal to 4, there will be 1, 0, 0. And we want to unset the k equal to 2 sets, which is 0, 1, 2. We want to unset this to 0. We just need to do X or 1 left shift k bits Y. Because as I said before, XOR only when 2 bits are different, it will give 1. Otherwise, it gives 0. So we know the case bit is 1, and now we XOR with 1. That means that these 2 bits are all 1, so they are the same. So the result will be 0. So we get this a result. So we set it to, we unset it. So we just make it to 0. This is the 3 commonly used operations. Another one is count how many bits are set. So given any number, we can quickly know how many ones in its binary representations. This example, if I equal to 10, then we call it integer bit count 10, we will return 2, because this 1010 is the binary representation of this decimal number 10. So we return 2. This is the API has been implemented by Java. So we can just call it. The last operation is also commonly used. Is iterate all the submasks of a mask. So what is a mask? A mask is just one state of this representations. So if n equal to 4, it actually have 2 to the power of 4 masks. So we choose any mask and we want to iterate all its submasks. Let's see example. If mask equal to 110 in binary, so in decimal it represents 5. So how to iterate all the submasks? Now in this number, we only have 2 bits are set. That is the first and the second bits have been set. So its submask should be either this has been set or this has been set. We cannot, or we never get this first or this zeros bit has been set because it does not belong to this mask. How can we understand it? You can see we have a set, and we are now have 2 persons in this set. This number 1 and number 2 person. So the subset of the current set is either number 1 person there or either number 2 person there. But we can never get the number 0 person there because it does not belong to the current set. So if you understand it, let's see. How can we iterate all the submasks? We can use a for loop. Int submask will first be initialized to mask, and when the submask is greater than 0, we let submask equal to submask minus 1 and mask. So how to understand it? Let's see an example. If mask equal to 110, just this example, first we set submask to 5, and then we go through this operation. We let submask 110 minus 1, so minus 001. We should get we borrow 1 from here. So 2 minus 1 equal to 1. And now we have 0, 0, and 1, 1. And then we end the mask. We end the mask is 1, 1, 0. Then we get 0, 0, 1. So this is one submask, 1, 1, 1, 0, 0. And then we'll continue. 1, 1, 0 minus 0, 0, 1. We go through this again. Then we borrow 1 from here. So 2 minus 1 equal to 1. And we left 1. And 0, 1, 1. And end the mask. That will be 1, 1, 0. Then we get 0, 1, 0. So this is another submask, 0, 1, 0. Then we do the same thing. 0, 1, 0 minus 0, 0, 1. That will equal to, we borrow 1. That will be 1, 0, 0, 1. And 1, 1, 0 will equal to 0, 0. So all the submasks we get is just these two. So does this be constant? Is this constant with what we saw before? So we have two persons here. The subset is either this person there, so this submask, or this second person is there, this submask. So it is constant with what we thought. So as you can see, this submask is actually in decreasing order. We get from the the largest submask and to the smallest one. Okay, that's all for today's video. Hope you can understand what are some common bit masking operations. Thank you for watching. See you next time.